Congratulations to those of you who are starting these notes. That means that you have completed the Algebra 1 curriculum and you are now working on geometry. So this will get you started for next year and you'll be ahead of the game. So the very first thing that you have to talk about in geometry is points, lines, and planes. Those are the basic foundations for everything else that you do in geometry. Now, point, that is something that most of you have already been dealing with. For most of you, when you think of a point, you think of something that goes on a graph or a coordinate plane. What you need to know about a point is first that it doesn't have an actual size. And it is used to represent a specific spot in space. And there are many different types of points. One example might be like a star in the sky representing an exact space. So you need to think of a couple more examples and put them out here. Okay? To sketch a point, you're just going to plot it and then put a big capital letter by it, not a lowercase letter. Okay? And then how do we name it? These are just named by a capital letter. So if we wanted to talk about this, which is point A, we would literally just write A. So if we were to add another one, this could be point B, or I could have one over here called point T, and we would call that B and T. The second thing is a line. The one thing that you need to know about a line is that it actually has no thickness or width. So it can be really, really fat, or it could be really, really, really skinny. It is used to represent a continuous set of points that extend indefinitely in both directions. In other words, it goes forever in both directions. So we'll put, it's a continuous set of points that go forever in two directions. And the two directions depend on which direction the line is going. So something that we might think of that's a real world example might be like the high wire. Okay, on a telephone pole. It doesn't really go indefinitely, but it goes probably as far as the eye can see. So if you can think of another real world example, go ahead and write that right here. Okay. Then to sketch it, we've got two options. There's one, okay, and that is a cursive M next to it. And the other one might look something like this. So this is line M, this is line CL. There is a distinct difference. This one is named by a lowercase cursive letter. Or this one, you can name it by using 2 points that are on the line. So again, we would call this line M, and this would be line CL. The most important thing is you must use the symbols. The line symbol with the arrows on the end. Alright, the last thing, or the main foundation for geometry, is the word plane. This is not an airplane. Okay, this is not something that goes up in the air and flies. A plane also has no thickness or width. nor does it have any depth, because a plane can be three-dimensional. It is a flat surface that extends forever. And this time it's in all directions. So a line only goes in two directions, but a plane is kind of like water when you spill it and it just starts to spread out and take over whatever it's on. Okay, that would be a plane. It spreads out in all directions. Okay, so a real world example would be like a street. Okay, it's a flat surface that goes forever in all directions. In a classroom, you might even say like the top of a desk. Even though it doesn't go on forever, the idea is that the top of a desk is a flat surface, so it would be considered a plane. Okay. To draw a plane, we actually use a parallelogram, and I didn't draw it very good. And out here, we could do a cursive capital letter. And then this could be a T, B on the inside. Okay? Or sometimes they may even label the corners. So we could call this R and S. It doesn't matter. So to name it, you want to name by a capital cursive letter. Or by 3 points in the plane or on the plane. So for instance, this could be plane L, or we could just pick any of these 3 points. So I could do ABS, I could do RAT, I could call it BRT. I could do ATB. So any 3 points that would be in or on the plane can be used to name the plane. So some other vocabulary that you need to know when we're talking about points, lines, and planes is the word collinear. Co is kind of like cooperate. It's working together. And this is to make a line. So collinear is points that form a line. So for example, if I have a point A here and a point B here and a point T here, I can draw a line through all 3 of these points, therefore these would be collinear. Okay? And we don't name it because it's not an object. Non-collinear is points that do not form a line. So I've got A and B here, but then if I put T over here, there's no way for me to connect those 3 points with one line. Therefore, these would be non-collinear. Okay. Okay. And our cheater method here would be same line. You can use the word co to mean same, so then this would be not the same line. And then we've got coplanar, is the same thing. We said same and planar sounds like the word plane. So this is points or lines in the same plane. And non-coplanar would be points or lines not in the same plane. So if this was our plane, coplanar would be if I had any points in here. So we would say that point C, T, L, and D are coplanar. So then if this was our plane, I'm just going to put plane L out here. I should have done that up here. And I could put C, T, D, and then out here point B. We could say that B is not coplanar with these since it's not in the same plane. So that's your basic vocabulary. Once you've got that basic vocabulary, there are some foundations that we need to cover. So let's look at the bottom. Okay? If you get these memorized, you pretty much have everything you need to know about points, lines, and planes down. How many points does it take to make a line? Well, if I only have 1 point, I can make a line, but I don't know if it's this one, or this one, or this one, or this one, or this one. I think you get the point. But if I put a second point, now my line has direction. The only way to connect those 2 points would be with this line. So we're going to say that 2 points make a line, and that would be why we name a line using 2 points. And then to reverse that, through any 2 points there is exactly 1 line. Okay, again, I cannot connect these 2 points using any other line. So then how many does it take to make a plane? Well, it takes 3 points to make a plane. And here's why we say this. If this is a cube, and I tell you plane AB, it makes it very difficult because if you notice, AB could be included in the top or it could be included in the back. So it wouldn't be until I added that third point C that you knew now I was talking about the back part of the box and not the top part of the box. Okay? So 3 points can make a plane. We're going to say 3 non-collinear make 1 plane. Notice these 3 are non-collinear. We can't make 1 line that connects them. But let's say I were to put a point here. A, T, B. Those are collinear. They are also coplanar because they could be on the top box or they could be on this back box. But I don't know which one we're talking about because they're collinear. So 3 points do make a plane. We're just not sure if it's the top or the back. But if you give me 3 non-collinear points, then I know that it's a specific plane. Okay? If 2 points are in a plane, then the line that contains those points is also in the plane. In other words, if I add a point over here, and now I talk about line AD, meaning there could be a line that connects A to D. A and D are both in this plane. Therefore, the whole line would be sitting in the plane. Okay. And then the bottom part, 2 lines intersect at A. Okay, if I do this, they intersect and they form a point. Then we've got 2 planes, so let's look at, let's say, this front box and the bottom. You should notice that they intersect right here. Intersect meaning where they touch. So if we're talking about this one and this front one right here, notice they touch all along this line. So they intersect to